In the mid-1950s, the United States was gripped by a fever known as atomic optimism. It was a time when engineers believed that nuclear power was the answer to every tactical problem on Earth. The U.S. Army was looking for a new kind of medium tank, one that could not only survive a tactical nuclear strike on a European battlefield, but also operate for weeks or even months without a single drop of traditional fuel. Enter the Chrysler TV-8, a machine so radical and so visually bizarre that it looked more like a prop from a high-budget science fiction movie than a functional weapon of war. Designed by the visionary minds at Chrysler's Special Projects Division, the TV-8 was built around a singular, revolutionary idea. What if you took everything, the crew, the ammunition, the engines, and the power source, and put it all inside the turret? The result was a tank that consisted of a massive 15-ton aerodynamic pod sitting on top of a surprisingly small and narrow-tracked chassis. It was a steel brain on wheels, a 25-ton experiment that aimed to redefine armored warfare for the radioactive age. The physical proportions of the Chrysler TV-8 were nothing short of nightmarish for a traditional tanker. The turret was a giant, watertight, egg-shaped capsule, nearly the size of a small house, which towered over the battlefield. The reason for this gargantuan head was twofold. First, the engineers wanted the tank to be fully amphibious. The massive volume of the turret provided enough buoyancy for the TV-8 to actually float. While other tanks needed complex snorkeling gear or floating screens, the TV-8 was designed to simply drive into a lake or an ocean and paddle across using two water jets located at the rear of the turret. Second, and more importantly, the turret was designed to house the atomic heart of the machine. The original blueprints called for the installation of a compact nuclear reactor in the rear section of the turret, which would provide steam to drive an electric generator, powering two massive electric motors. It was a self-contained, nuclear-powered fortress that could, in theory, drive from New York to Los Angeles without stopping for gas, all while shrugging off the pressure waves of nearby nuclear explosions. Inside that massive steel egg, the crew of 4 lived in a world of high-tech claustrophobia. Unlike traditional tanks where the driver sits in the hull, in the TV-8, the driver was placed high up in the front of the turret, surrounded by a battery of closed-circuit television cameras. This was the first tank in history designed to be operated entirely through remote vision. Because the engineers wanted to eliminate the weak points of traditional vision slits or periscopes, they planned to wrap the turret in armor and have the crew see the world through electronic screens. This allowed the turret to have a smooth, sloped, and incredibly thick outer shell designed to deflect armor-piercing shells and provide maximum protection against the intense gamma radiation of a nuclear battlefield. The TV-8 wasn't just a vehicle, it was an environmental capsule, a pressurized, lead-lined sanctuary designed to keep 4 American soldiers alive in the middle of a radioactive wasteland. Subscribe to the channel, hit that like button, and stay with us until the very end, because you are about to discover the hidden suicide shield mechanism that made this tank a death trap for its own infantry, and the terrifying meltdown scenario that forced the U.S. Army to kill the project before the first reactor was even turned on. If you have a passion for the giants of the Cold War and the machines that dared to challenge the laws of common sense, you are in the right place. We are cracking open the radioactive shell of the Chrysler TV-8. The internal layout was a masterpiece of radical consolidation. By moving the heavy engine and fuel systems into the turret, the chassis could be made incredibly light and simple. The small, tracked lower body contained only the electric drive motors and the suspension, making the TV-8 significantly more agile in mud and soft soil than a standard M48 Patton. But this top-heavy design created a terrifying physical reality. The center of gravity was so high that if the tank attempted to climb a steep embankment or take a sharp turn at high speed, it risked toppling over like a giant steel toy. The crew would be trapped inside their floating egg, rolling down a hill with a live nuclear reactor behind their heads. It was a machine that demanded absolute precision from the driver, even as they stared at a flickering black and white screen in a windowless room. The TV-8 was the ultimate symbol of engineering hubris, a machine that prioritized theoretical power over the brutal, messy reality of ground combat. The most controversial and terrifying feature of the Chrysler TV-8 was not its bizarre shape, but what lay hidden in the rear section of that massive, bulbous turret. While early prototypes were planned to use a conventional Chrysler V8 engine coupled to a generator, the ultimate vision for the project was the nuclear vapor drive. The engineers proposed installing a compact, high-temperature nuclear reactor directly behind the crew compartment. This reactor was designed to heat a closed-loop system, creating high-pressure steam that would spin a miniature turbine to generate electricity. This electricity would then be funneled down through the turret ring to the massive electric motors in the chassis. This meant the TV-8 was essentially a land-based nuclear submarine. It offered a theoretical range that was limited only by the mechanical wear of the tracks and the endurance of the crew. In an era where fuel logistics were the greatest weakness of any armored division, a tank that never needed to refuel was the ultimate tactical dream. A weapon that could drive across entire continents without ever seeing a tanker truck. However, placing a live nuclear reactor inside a mobile, vibrating and heavily targeted combat vehicle created a list of engineering nightmares that were almost impossible to solve. The primary issue was shielding versus mobility. To protect the four-man crew from the lethal neutron and gamma radiation emitted by the reactor, the TV-8 would have required massive lead and polyethylene shielding. But lead is incredibly heavy, and adding enough of it to make the tank safe would have pushed the weight far beyond the 25-ton limit, causing the floating turret to sink like a stone. The Chrysler engineers proposed a radical solution. They used the tank's own fuel and water supplies as a secondary radiation shield, surrounding the reactor with layers of liquid. But this meant that if the tank was hit and the fluids leaked out, the crew would be exposed to a silent execution of radiation within minutes. They were sitting in a high-stakes gambling match where the prize was infinite range and the penalty was a slow, agonizing death from radiation sickness. The armament of the TV-8 was equally unconventional, designed to complement its high-tech nature. Mounted in the front of the steel egg was a 90mm T-108 smoothbore cannon. But unlike a standard tank where the gun recoil is absorbed by the heavy chassis, in the TV-8, the gun was rigidly fixed to the turret itself. To aim the gun, the entire turret had to move. This required a massive, high-torque hydraulic system that could pivot the 15-ton pod with surgical precision. The ammunition was stored in the rear of the turret, separated from the nuclear reactor by only a thin armored bulkhead. This created a terrifying chain reaction risk. A single enemy shell penetrating the rear armor could not only detonate the 90mm shells, but also rupture the reactor's cooling system, leading to a tactical meltdown right in the middle of the battlefield. The TV-8 wasn't just a threat to the enemy. It was a potential dirty bomb waiting to be triggered by a lucky shot. The integration of the closed-circuit television CCTV system was another layer of technical madness. Because the turret was a smooth, windowless shell designed to deflect nuclear thermal radiation, the crew was completely blind to the outside world without their electronic monitors. This was 1955, the era of vacuum tubes and grainy black and white displays. The driver and commander had to rely on external camera pods that were vulnerable to dust, mud, and small arms fire. If an enemy soldier simply threw a bucket of paint over the camera lenses, the most advanced tank in the world would be rendered instantly useless. The U.S. Army's top brass was deeply skeptical of this electronic blindfold. They feared that in the chaos of a real battle, the vibration of the nuclear turbine and the shock of firing the 90mm gun would cause the sensitive vacuum tubes to shatter, leaving the crew trapped inside a lightless steel tomb, unable to see the enemy that was about to destroy them. But the most disturbing aspect of the TV-8's design was the Infantry exclusion zone. Traditionally, tanks and infantry worked together, with soldiers often using the tank as cover or even riding on the back. But you couldn't stand anywhere near a TV-8 while its reactor was hot. The unshielded radiation leakage, combined with the extreme heat being vented from the cooling system, would have been lethal to any unprotected soldiers in the vicinity. The TV-8 was designed to be a lonely hunter, a machine that was too toxic to work with its own army. It was a weapon of pure, unadulterated atomic fire, a machine that turned the surrounding environment into a no-go zone simply by existing. The Chrysler engineers had built a masterpiece of theoretical power, but they had forgotten that a tank is not a laboratory. It is a tool of war that must survive in the mud, the blood, and the unpredictable chaos of a world that was not ready for a nuclear-powered egg. The most audaciously bizarre feature of the Chrysler TV-8 was its intended role as a fully amphibious combat vehicle. Most tanks of the 1950s struggled to cross a shallow river without sinking into the mud, but Chrysler's engineers envisioned the TV-8 as a machine that could literally drive off a transport ship in the middle of the ocean and paddle its way to the shore. The massive, egg-shaped turret was not just an armor shell, it was a pressurized, air-filled displacement hull. Its enormous volume was calculated to provide enough buoyancy to keep the entire 25-ton vehicle afloat, even with a heavy 90mm cannon and a nuclear reactor on board. To move through the water, the TV-8 was equipped with two powerful hydrojet pumps located at the rear of the turret. This meant that the tank didn't just float passively. It was a nuclear-powered boat with tracks. The U.S. Army was fascinated by the idea of a transoceanic armored force that could bypass destroyed bridges and port facilities, landing anywhere on a coastline like a mechanical sea monster. However, the reality of testing the full-scale wooden mock-up revealed a catastrophic design flaw that no one had fully anticipated: the horizon problem. Because the turret was so massive and the crew sat so low within its rounded belly, their natural line of sight was almost non-existent. When the tank was in the water, the crew was effectively staring at the waterline. To fix this, the engineers doubled down on the CCTV camera system, mounting lens pods on the highest point of the turret. But during simulated wet trials, they discovered that even a small amount of sea spray or light rain would coat the camera lenses, rendering the crew completely blind. Imagine being trapped inside a 25-ton steel egg, bobbing in the waves of a turbulent ocean, with a live nuclear reactor humming behind you, while your only eyes are obscured by a film of salt and mud. It was a recipe for a high-tech disaster. The TV-8 was a machine that was supposed to conquer the elements, but it was being defeated by a few drops of water. The mechanical complexity of the dual-element drive was another engineering nightmare. To transition from water to land, the TV-8 had to switch its power flow from the hydrojets to the electric motors in the chassis. This required a sophisticated power management system that, in 1955, was prone to frequent short circuits and overheating. Furthermore, because the turret was the source of all buoyancy, the tank was dangerously top-heavy while floating. In even moderate sea conditions, the TV-8 risked a fatal rollover. If a wave tilted the turret beyond a certain angle, the center of gravity would shift, causing the tank to capsize. The crew would be inverted under the water, sealed inside their lead-lined tomb with no way to escape, as the heavy chassis would act like an anchor, dragging the steel egg to the bottom of the sea. The amphibious miracle was looking more like a specialized way to drown America's best tank crews. Inside the turret, the heat management for the nuclear reactor was proving to be an impossible puzzle. A nuclear reactor generates a staggering amount of waste heat, which is usually cooled by a massive supply of water in a ship or a submarine. But in a tank, you are limited by the size of your radiators. Chrysler's engineers realized that to keep the atomic brain from melting down, the TV-8 would need massive cooling vents. These vents, however, were holes in the armor that could suck in radioactive dust, or, even worse, allow water to flood the reactor during amphibious operations. The TV-8 was caught in a thermal trap. It needed to be sealed tight to be safe from radiation and water, but it needed to be open to the air to keep from overheating. The interior of the crew compartment was projected to be a sweltering 100 degrees Fahrenheit, even in cold weather, turning the environmental capsule into a literal pressure cooker for the 4 men inside. But perhaps the most terrifying realization during the mock-up phase was the recoil instability. When the 90mm smoothbore cannon was fired, the massive energy of the shot was transferred directly into the buoyant turret. Engineers feared that if the gun was fired while the tank was floating, the recoil could actually flip the tank backward, or, at the very least, push it deep enough into the water to submerge the air intakes. The TV-8 was a machine of constant contradictions, a tank that wanted to be a boat, a fortress that wanted to be a laboratory, and a weapon that was becoming more dangerous to its operators than to its enemies. The U.S. Army's evaluation teams began to write reports that were increasingly biting, calling the project a mechanical hallucination that ignored the basic laws of physics in favor of atomic-age fantasy. The tactical vision for the Chrysler TV-8 wasn't just about winning a single battle. It was about the long war of attrition in a world devastated by nuclear exchanges. Because the tank was powered by an atomic reactor, the U.S. Army planners imagined steel colonies, groups of TV-8s that would operate behind enemy lines for weeks without ever returning to base. This meant the crew of 4 had to be able to eat, sleep, and survive inside that 15-ton steel egg without ever opening a hatch to the poisoned air outside. The interior was designed with integrated waste management systems and a miniature galley for heating atomic-age rations. It was a form of armored isolation that had more in common with a space capsule than a tank. The crew were essentially prisoners of their own machine, living in a windowless, vibrating room, lit by the eerie glow of black and white television monitors and the flickering dials of a nuclear control panel. The psychological toll of being trapped inside a lead-lined sphere, knowing that only a few inches of steel and water shielded you from a hot reactor core, was a factor that Chrysler's engineers had barely begun to calculate. But as the Cold War progressed, the emergence of a new generation of anti-tank weapons began to tear the TV-8's logic apart. In the mid-1950s, the development of the HEAT, high-explosive anti-tank round, changed everything. These shaped charges could burn through feet of solid steel by focusing a jet of molten copper. For a traditional tank, a HEAT round was a disaster, but for the TV-8, it was a global catastrophe. Because the reactor, the fuel, the ammunition, and the crew were all crammed into the same bubble turret, a single successful penetration would lead to a total and instantaneous loss of the vehicle. But there was a darker realization. If a HEAT round, or a simple RPG, rocket-propelled grenade, struck the rear of the turret and ruptured the reactor's primary cooling loop, the TV-8 wouldn't just be knocked out. It would become a miniature Chernobyl in the middle of a German village or a French farm. The U.S. Army began to realize that deploying a fleet of TV-8s was the equivalent of driving thousands of unshielded, vulnerable nuclear bombs into the heart of Europe. The risk of battlefield contamination was a logistical nightmare that the Pentagon could no longer ignore. If a TV-8 was destroyed, it couldn't be towed away by a standard recovery vehicle. The wreckage would be so hot with radiation that it would require specialized robotic equipment and lead-shielded cranes just to clear the road. A single lost tank could deny an entire strategic bridge or a vital mountain pass to both sides for years. The TV-8 was a weapon that caused environmental blowback. It punished the army that used it almost as much as the enemy it was meant to fight. Generals began to ask, do we really want a tank that turns every victory into a permanent dead zone? The steel egg was becoming a strategic liability, a machine that threatened to leave the U.S. Army stuck in a radioactive mire of its own making. Inside the Chrysler design labs, the weight of the shielding was still the ghost in the machine. To keep the tank at 25 tons and still maintain the buoyancy required to float, the engineers had to thin out the armor in certain areas. This led to the vulnerability paradox. To make the tank safe from its own reactor, they had to make it weak against enemy fire. The result was a tank with a giant, fragile head that was an impossible target to miss. At nearly 13 feet tall, the TV-8 would have been visible from miles away on a flat battlefield, a massive silhouette that invited every enemy gunner to take a shot. The aerodynamic pod that looked so futuristic on a drafting board was, in reality, a magnetic bullseye for anti-tank missiles. The very features that made it an amphibious nuclear marvel made it a death trap in a conventional high-intensity conflict. The final realization that broke the project's back was the maintenance wall. Unlike a standard diesel engine that any Army mechanic could fix with a wrench and a manual, the TV-8's power plant required nuclear physicists and specialized radiation handling facilities. If a TV-8 broke a fan belt or a turbine blade in the middle of a forest, there was no way to repair it in the field. The tank would have to be abandoned and, likely, destroyed by its own crew to prevent the nuclear technology from falling into enemy hands. The Army's logistical experts concluded that for the price of one nuclear TV-8, they could field 10 conventional M48 Patton tanks that were easier to fix, safer to operate, and didn't risk melting down if they hit a landmine. The atomic bubble was about to burst, not because it couldn't be built, but because the U.S. Army finally looked at the steel monster and realized it was a machine designed for a war that no one could survive. By late 1956, the high-altitude euphoria of the atomic age was finally meeting the cold, hard floor of military reality. The Chrysler TV-8 project, which had begun as a bold vision of a nuclear-powered future, was abruptly halted. The U.S. Army's Armor Board conducted a final devastating review that stripped away the futuristic glamour of the steel egg. Their conclusion was surgical and final. The TV-8 offered no significant tactical advantage over conventional medium tanks that could justify the astronomical cost and the terrifying risks of a mobile nuclear reactor. The dream of a tank that could float across oceans was dismissed as a logistical fantasy. After all, why build a tank that can swim when the Navy already has specialized landing craft that can deliver 100 battle-proven Pattons to any shore? On a cold morning in April, the funding was pulled, the blueprints were stamped canceled, and the TV-8 was officially relegated to the graveyard of what-if military history. The fate of the only full-scale wooden mock-up of the TV-8 is a mystery that still haunts tank historians. After the project was axed, the massive, bizarrely shaped turret was dismantled. There are no surviving prototypes in museums, no rusted hulls in the desert. Only a few black and white photographs and the original technical drawings remain as evidence that the U.S. government once seriously considered putting a nuclear reactor inside a tank's head. The TV-8 was a victim of design oversaturation. The engineers tried to solve too many problems with a single vehicle. They wanted a tank, a submarine, a nuclear power plant, and a television studio all in one 25-ton package. In the end, they created a machine that was mediocre at everything and dangerous to everyone. It was the ultimate steel dead end, a branch of the evolutionary tree of armored warfare that withered because it was too specialized for a world that was already moving toward more practical, reliable weapons. But the ghost of the TV-8 still lingers in the halls of modern military design. Today, as we look at the development of high-energy laser weapons and electromagnetic railguns that require massive amounts of electrical power, the idea of a nuclear combat vehicle is being quietly discussed once again in secret research labs. Modern materials like carbon fiber composites and advanced depleted uranium armor might solve the weight problems that killed Chrysler's dream in the 50s. And with modern AI and digital sensor suites, the electronic blindfold that terrified 1950s generals is now standard technology in tanks like the M1A2 Abrams. The TV-8 wasn't just a crazy idea, it was a prophecy of total automation, Born 60 years too early for the technology needed to make it work, it stands as a monument to a time when American engineers weren't afraid to fail, and when the word impossible was just a challenge waiting for a nuclear solution. The legacy of the Chrysler TV8 is a chilling reminder of the atomic delusion. It shows us a world where we were willing to ignore the most basic safety protocols and the health of our own soldiers just to achieve a marginal gain in range or firepower. The steel egg was a beautiful, terrifying, and fundamentally broken vision of a future that never arrived. It was a machine designed for a war of total extinction, a war where the survivors would be trapped inside lead-lined capsules, watching the end of the world on a flickering black and white screen. As the archives of the 1950s are slowly declassified, we see more and more of these mechanical nightmares, proving that during the Cold War, the greatest threat to humanity wasn't just the enemy. It was the madness of our own ambition. I want you to leave a comment with your honest thoughts. If a nuclear-powered tank was built today with modern safety tech, would you want to be the one sitting inside that lead-lined turret, or is the idea of a mobile meltdown still too much of a risk? And tell me, do you think the TV8's bizarre design was a work of genius that was ahead of its time, or just a colossal waste of taxpayer money during the peak of the Red Scare? If you live for the stories of these forgotten giants and the nuclear ghosts of the 20th century, hit that subscribe button and leave a like. We are the channel that uncovers the gigantic monsters that the world was too afraid to deploy. See you in the next deep dive into the vault of experimental madness.